Hello everyone, welcome to the third lecture. This is part A of the third lecture. I hope that you have grasped all the ideas presented during the first 2 weeks. And if you have any questions or misunderstanding of any topic, contact me via email or Microsoft Teams or in my office hours, or you can simply contact one of the assistants. Today's lecture will be about applications of systems of linear equations. Actually, systems of linear equations arise in a wide variety of applications. You will look at two applications. The first application shows how to fit a polynomial function to a set of data points in the plane. The second application focuses on networks and Kirchhoff's laws for electricity. So we have two objectives today. The first is to set up and solve a system of equations to fit a polynomial function to a set of data points, and to set up and solve a system of equations to represent a network, either a traffic network or an electrical network. First of all, I would like to have a quick look at what's meant by polynomial curve fitting. So, assume that you are given the following graph that passes through the depicted 3 points. We have here 3 points, 1 and 4, 2 and 0, 1 and 4, 2 and 0, 3, 12. This number represents x coordinate, and this number represents y coordinate. So we have here the x and y coordinates for 3 points. What am I seeking is, I'm seeking an equation that represents and fits the curve. So our aim to find an equation that represents the curve. How can I get an equation that represents a curve? Equation, first of all, equation must be polynomial. Do you know what's meant by polynomial? So let me show you what is the meaning of polynomial. Polynomial comes from poly, meaning many, and nomial, in this case, meaning term. So it says many terms. So polynomial means many terms. You should be aware that any equation must be many terms to represent a curve, since one term wouldn't represent a curve. A polynomial can have, so if there is any restrictions in writing any polynomial, yes, of course, we have here the following. A polynomial can have constants, variables, and exponents. However, it shouldn't have division by a variable. So be aware and keep in mind this note: never division by a variable. In addition to that, one or more terms, but not an infinite number of terms. If the polynomial consists of infinite number of terms, it would be a series. It would be a series. Okay. How could we implement curve fitting?